This is Richard Rogers and Arnold doing a problem from Chapter 8, number 15. A normal population has a mean of 63 and a standard deviation of 14, and a random sample of 25 has been selected.
So the first thing is to draw the graph. This is the normal distribution curve, bell shape. You have to find, and this is the mean, which is 63, and we have the standard deviation, which is 14. The sample is 25. Now we have to find the standard error of the mean, and the standard error of the mean is, the formula is standard deviation divided by the square root of the sample.
And when you plug in those numbers, your standard deviation is 14 divided by the square root of your sample, which is 25. So that when you compute that, you get 14 divided by 5, and ultimately your standard error equals 2.8. Then you plug that in to find your z-score.
Now we have to compute the probability of the sample mean, which is greater than 65. So here we have 65. So they need to find the probability of this area.
Which, to do that, you plug in the number you're looking for, greater than 65, minus 63, your mean, over the standard area, which is 2.8. When you do that calculation, you get a z-score of 0.71. If you look up your z-score in your table, the probability is 0.2611.
So this area is 2.2611, but they need to find this area, since the total area under the curve is 1, so each part is 50-50, so 0.5. So to find the probability of the sample mean, which is greater than 65, you have to compute 0.5 minus 0.2611, and the answer is
0.2389.
0.2389. The next thing is to find the probability of the sample mean, which is less than 60. So they need to find this area.
And to find that area, you find the z-score by using your number less than 60, what you're looking for, minus 63, your mean, again over 2.8, your standard error. When you compute this z-score, you get a z-score of negative 1.07, which is the same as your 1.7. It's interchangeable. And when you find that probability, it equals 0.3577, which is this area.
This area is 0.3577, same thing as this one. So the probability of the sample mean, which is less than 60, is 0.5. Take away minus
3.577.
3.577, which is
0.1423.
Now we have to find the probability of the sample mean, which is between 60 and 65. So we have 60 and we have 65.
And to find that, all you have to do is add the probabilities that you got for your first z-score, 0.71, which was 0.2611, and the probability from your second z-score, 1.07, which is 0.3577. And when you compute that, your final answer is 0.6188.
Yeah.